starting recording. So I have the web page up here to remind folks that next week you have an assignment due, but it's moved to Wednesday. So it still says that the wrong day on the top of the homework. I will fix that after class. That's an HTML thing. But I wanted to ask if anyone had questions about this so far, and just to go over briefly sort of some of the ideas and the questions that I've gotten so far from the folks who have started working on it. So any questions off the top of your head that anyone wants to ask about homework? And if your question is, that's funny that you think I've opened it already since it's not due since Wednesday, that's fine too. Well, it'd be like a rhetorical question, like, really? You think I've opened this?
I already sent it to you.
Yeah, I'm sure. That's good. Well, this is, so all of my homework stories are based on like real life things that I make into homework problems, and this is no less. So you are going to be predicting in a fictitious study whether or not someone gets a job as your binary outcome, a job offer, from the number of papers they have, the number of posters, and their level of quantitative training. Those are the variables in the story. So you will use the same procedures that we've been going through in example 2A. You can use that as a baseline. And I have, let's see, section 1, for instance, the extent to which employment can be predicted from additive main effects for papers and posters. So that is meaning no interactions, additive, not over or under additive. So not in the story yet is quantitative training, just these two variables. So the first thing I'm going to ask you is -2 log likelihood. That tells me if you have the right stuff in your model. Question?
If we said multiplicative effects, that would be an interaction.
Yes.
Because the effects multiply.
Yes. Yes. I would probably say, I would word it differently than that, but that is what that would mean. Yeah, I was trying to convey the idea that this is not an interaction, just these two predictors itself. So I'm asking for -2 log likelihood because that tells me that you have the right ingredients in your model. You have the right outcome, you have the right predictors. Test statistic for the significance, that tells it whether or not we have a significant prediction. And then we have the results. So I'm asking for slopes and logits and the corresponding odds ratios. So you can find those in your output. Odds ratio is e to the logit slope. So exp is the function. And then I have a question that I've already gotten multiple questions about. This one, enter the slope difference in logits for the number of posters versus the number of papers. So both of these things are in the same metric in that we have like one, this means one more. So it's a reasonable question to ask which is more important, which has a bigger effect on the logit of getting a job. So the difference in logits is something that you can compute with a calculator if you wanted to, but you won't get a p-value for the difference that way. We have to ask for it as a linear combination of the number of papers minus the number of posters, those two slopes. That uses GLHT in R or LinCom in Stata. I'll show you examples of those today in the interaction model in terms of the process. And then the next question is asking for the odds ratio. So the order of operations here is find the difference between the slopes and logits first. Verify that that's correct. If it's not correct, you may have it flipped in terms of the sign. Then you make an odds ratio of that difference. If you try to take the difference of the odds ratios, it won't work. Order of operations. Logits first, then odds ratios. Okay. Any questions about that? All right. Then the next model, so this is what I mean when I said before, if once you get all the numbers correct, I would come down here and start answering the questions because then you're interpreting this model. So for instance, was the improvement in the model significant or non-significant? Was the logit of a job offer higher or lower, significantly or not? And then to what extent do these things matter differentially? Then we add in controlling for a level of quantitative training. So this is a categorical predictor. It's low, medium, and high. So in the instructions, it tells you how to set up your model with respect to centering that. I've instructed folks to make low the reference group and to create indicator codes for low versus medium and low versus high. So then you would enter that into the model, answer the questions about what you have found, answer the questions about what the numbers mean, and then examine the extent to which the effect of number of papers depends on level of quantitative training. Now, what am I asking in those words?
Moderation.
That's an interaction term, exactly. So one interaction, conceptually, number of papers being moderated by training. However, how many variables does it take to capture the effect of training? It takes 2. So it will end up being 2 interactions that work together to differentiate the slope for number of papers across levels of training. And since I made the data up in this fake world, quantitative training is going to be good for you. Okay? Spoiler alert, right? Of course I set it up that way. And then we have, the last but not least, predicted probabilities. So this is margins in Stata you can use for this, and prediction in R, examples of how to do that. So then if this were a real analysis that you were trying to describe to someone, you would build a figure that illustrates these patterns using these predicted probabilities. But I haven't figured out a way to take images in terms of this homework system and have it automatically grade them, so we're not going to do that. But that would be the next step. Okay, any questions on any of that? Due next Wednesday. That means on Tuesday I will ask again if anyone has questions. And questions over email are fine as well. All right, then we have one more model to talk about in example 2A that has interaction terms in it. Would it be helpful to go back over the main effects model first, or do we feel good about that? Because we've done this, I think, at least once or twice. Any thoughts? I'm in example 2A on page 4. Like re-go over or review? See, those are 2 different terms. Re-go over, yeah. Re-go over means present it as if you've never heard it before. And review means like take the shortcut version.
Shortcut.
Okay, cool. So this is a model. The log of the odds, right, of the probability of a 1. So like that's what we're trying to get here. This is a shorter version of writing it that removes the probability part, but we've got this thing. Yeah, I need to fix this actually. This is too short. This is introducing inaccuracy. Never mind, I'll fix it. Beta 0 in this model. This is going to be what? Predicted logit, predicted odds, or predicted probability?
Logit.
It's predicted logits for what kind of person in my story? GPA of 3. Remember, we're predicting the probability of wanting to go to grad school. So GPA of 3, somebody whose parents went to grad school, yep, and private undergrad. So these are main effects. Are these marginal or conditional in this model?
Marginal.
Marginal. That means this is the effect of GPA for everybody. This is the effect of parents having a graduate degree for everybody. They're additive, marginal, yep. So we looked at the logit slopes. All 3 of them were positive, meaning that as these variables increase, you're more likely to want to go to graduate school. These are in logits. Can I say that the predicted logit increases by 0.55 for every unit GPA? Can I say that? The predicted logit increases by 0.55 per unit GPA?
Logit.
Yeah. Can I say the predicted probability increases by 0.55 per unit GPA? No, I cannot. So these are in logits. We can't talk about what they do to probability. But what we can do is get predicted probabilities out of the model. So this is an example and a limited way to do that. For instance, margins in Stata says, show me predicted probabilities. These are predicted logits in this case, predict XB, for 2, 3, and 4, essentially, starting at -1, increments of 1 up to 1, predicted logits. If you take off the predict XB, we get predicted probabilities. So you can tell it what range of your predictors you want in here, and it will spit out all the combinations. The tricky part is figuring out which is which. Odds ratios then. Stata folks, you have to rerun your model with 2 little letters. OR stands for odds ratio. R folks, I did you a solid and made a nice little function that does stuff.
It was
Well,
beautiful.
I know. Now, unfortunately, not all of the models in this class will be functionable. Like the ordinal models would not cooperate with that, so I couldn't make nice little functions for that, but we'll see that. Not everything can be a nice little function, but I'm working my way there. So what I did was take the default output and add this column to it at the end, which is exp to whatever that slope was. So your odds ratios, if you use my function, are at the end of this. If you don't, you'll have to ask for it separately, and there's examples in the online files that show you how to do that. Likelihood ratio tests, what's this for?
Can I ask you a question?
Yeah, hit me.
So the odds ratio in the function that you made returns the same information as the odds ratio in the function that was in the
Is that like a BF test?
Yes, yes, it is like the F-test, exactly. So yes, the odds ratio in the code, there is someone else made a package that does odds ratios that you can use, or you can just literally manually exp to the number.
and it gives the same estimate, but is there, like, do we have like a p-value for the odds ratio, or we only do the p-value for the logic?
They are one and the same.
They're exactly the same.
Yep, it's not new information. It's just a transformation of scale.
Okay.
But these odd ratios are considered effect sizes. Now, I don't think they're useful for two reasons, but I'm going to teach them to you because the world uses them. One of the reasons is the asymmetry of how positive and negative slopes are codified into odds. So positive slopes and odds range from what to what? Yeah, close. For positive logit slopes correspond.
Like
Oh,
one infinity?
sorry, I meant
Yeah.
symmetry.
Yeah, 1 to positive infinity is a positive slope in logits. What's a negative slope in logits correspond to in odds ratios?
0, 1.
0 to 1. So like the number line is very condensed for negative slopes relative to positive slopes. So I don't like that asymmetry.
The symmetry is because under the numerator.
Good,
and
Zoomers.
the denominator.
Yes, so an odds ratio is a ratio of odds. So it's like the top of it is the probability of a 1 given this or this, and then the probability of a 0 given this or this. So I have that in the slides somewhere, but that's, each of the logit slope is how you get that number. The other reason that I don't like it, and you'll see this in Vladimir's presentation as well, is that like for these two variables are binary. So a shift from 0 to 1 is all that is possible. That's the entire range of that variable, whereas GPA is per unit. And GPA can go theoretically from 0 up to 4 or more. So this is covering only part of the possibilities for that variable, not the whole thing. So some of these odds ratios might be lower because they're in per unit increments as opposed to moving from nothing to everything. So I find that also not dissatisfying. But these are effect sizes. Then the question that I had was about likelihood ratio tests. Before I do that, are there any other questions about logit slopes and odds ratios?
Although it's not necessarily about concept, but for finding the odds ratio, when we're going from the logits and using the, not the logits, but you're using your, can you go to the right map a little bit? Or smaller, or, yay.
Yep.
So, when using the exp function for exponentiation,
Mm-hmm.
would 2 decimal places cut it for accuracy, or would you use more than that?
I would use as much as possible.
Well, I use as much as possible,
Yeah.
but I'm only asking because, we're reporting, into 2 decimal, I just want to make sure I'm,
Yeah, I think that you would compute it with as much precision, and then you can round it for reporting.
You can pare back, right?
Yeah. So let
Very
me
good,
find,
okay.
here's the slide that I wanted about odds ratios. This is slide 23.
Okay.
So an odds ratio is a ratio of odds. So we have the probability of a 1 versus 0 in the numerator here. That's one set of odds if x is 1. And then we have the same thing if x is 0. So what are the odds if you have this trait? What are the odds if you don't? So it's a ratio of odds. Okay. And then it's the last column here, and what I computed. Question or head?
Oh, I'm thinking. now.
Okay.
I think better with my hand up.
Oh, that's fair.
apparently.
Yeah, when I'm doing that, I do this. Like I'll just sit there and do this. So
Yeah.
then you can tell I've been working hard because my hair is like a mess on the side that I keep, fussing with it. But okay, so then likelihood ratio test.
Mhm.
This thing is analogous to our F-test in regression for how well the model predicts the outcome.
Mhm.
You can make F-tests in these models instead, however, without denominator degrees of freedom, they are chi-squares. And I have found through trial and error with these models that they don't always return the same value across data in R and SAS.
Awesome.
I know, it's great, it's super fun. The way the standard errors are computed is slightly different, and that translates into different Fs. But this always works across programs. So likelihood ratio test is an idea of model comparison. We're starting with an empty model, and we're seeing how much taller the model is after adding the predictors, how much taller the data are, according to this model. So the command for that in R is ANOVA. The command for that in Stata is, let's see, where did I get that? Did I have that? Oh, it's done for you, that's right. I'll show you a command to do it in just a minute, but we don't need to. Stata users, you will find your likelihood ratio test result for the model right here. Here we go. Back up, there. So the numbers to report then are these three. Degrees of freedom, that's like numerator degrees of freedom. Why 3? Where'd the 3 come from?
Because we got 3 slopes.
That's it, 3 slopes, right here. Ding, ding, ding. Your test statistic is this thing called deviance. That is the difference in log likelihood times -2 relative to the empty model. And then the p-value that goes with that, referencing a chi-square distribution with 3 degrees of freedom, is this right here. So it will look like one of these two things when you write it up. Degrees of freedom in the parentheses. We're not doing R-square. I also had a question over email about the polychoric and tetrachoric correlations. That's not in your homework. One of the reasons is because it will disagree across programs, but the other reason is that the Stata package that has it doesn't install correctly anymore in certain versions of Stata. So I wrote the author and he sent me the code, and I tried to use it on my machine and it worked, but then I tried to use it on the virtual desktop and it wouldn't let me because you have to move things into the C drive and we don't have access to that for admin. So I won't be able, if it doesn't work for you, I won't be able to fix it very easily. But you don't need it for this class. I just need to give it to you for your future reference. So hopefully it will get fixed at some point because it's a nice little package. So thank you, Stas. Okay. Interaction terms. We ready to do this? Yeah. The good news is you already know how to do this. There's nothing new about it except you're predicting logits. So let's talk about conditionality here. My slope of GPA, marginal or conditional? Conditional, because it's not just the slope of GPA because it shows up here and here. So when would these things drop out? Yeah, when grad is 0 and private is 0. Yeah, so that's what this then has to mean. This is the GPA slope specifically for people whose parents didn't go to grad school, who went to public school. How about grad? Is that conditional or marginal? Conditional, because this is the grad slope specifically. When this drops out, GPA of 3. And same thing for private. This is conditional on GPA of 3 because of this interaction term. Yeah. So to enter interactions, this is Stata output first. Hashtag or pound sign, take your pick, depends on how old you are. I'm going to call it a pound sign. It creates interaction terms on the fly. Our likelihood ratio test is still significant, but now it's degrees of freedom 5, because we got, say it with me, 5 slopes. Yeah.
This question here, so it's 5 slopes if we're comparing this to the empty model, but if we're comparing it to the main X model, it would just be 2.
Yes, that was foreshadowing. I was about to say that. It's brilliant. Yes. So this does not answer the question, did the 2 interaction terms help? This answers the question, does the model help?
Compared to the empty model.
compared to having no predictors. So we'll have to manually get a test for just the two slopes that are new. And by manually, I mean write more code, not like compute it yourself. I know that things can be computed, but in terms of reproducible research, it's much better to let the computer do the computing, because then you know for sure it's right, and your program will work even if things change.
Or recycle it for a different project.
Exactly, then you can recycle your work. Yep. So likelihood ratio test is the command that does this. And to use that in Stata, two things had to have happened already. You need to have saved the results under estimate store and give it a name for the interaction model. So I called the name of the model interact, and I had done the same thing for the main effects model as well. So then you can ask it to do LR test, which stands for likelihood ratio. The model that is bigger with more parameters goes first, followed by the one that's smaller. So now we have this LR chi-square of 2 degrees of freedom. That tells me that it's the right one, and it's not significant. P-value is 0.42. So it looks like the two interactions did not improve our prediction, as I said. But we can still go over them. In terms of getting predicted probabilities, because of the interactions, I'm probably going to want more. So I have a range of GPA from 2 to 4. I have 0s and 1s for grads, and I have 0s and 1s for public and private. These are going to be in logits. Now here's how I get conditional slopes. We said before that this is the slope of GPA specifically when graduate and private are at 0, right? Well, what if I want to know the GPA slope for somebody whose parents did go to grad school? Can I figure that out?
The inverse. Does it inverse?
That would get us from logits to probabilities. So we're not there yet, but we're going to get there eventually.
Put a 1 in for your grad?
Yeah, so this is, like, if I want to say what would it be if grad was 1, I would start with this number, and I would add that one to it. If I wanted to know what the slope of GPA would be for somebody who went to private school instead, I start with that one, and I add to it. So I can do this on a calculator, and actually, if you want to check if your code is doing what you think it should, a calculator will tell you because you get the same number. But what I won't get is the standard error and the p-value. So I will show you. Most of you have seen this before, but if you haven't, welcome to the wonderful world of linear combinations. Yay! So the model implied GPA slope is the main effect plus the 2 GPA interactions, where we have to fill in the values of the moderator for who we want the GPA slope for. So to do that in Stata, there is a command called lincom, stands for linear combinations, and what I am doing is mapping this equation directly onto the code. So for the reference, I fill in zeros. Question?
Yes. Looking at beta 4, it looks like the name within the parentheses changed. Did you just rename that
Oh,
interaction?
yeah, I had called it that before,
Okay.
and then I decided I didn't like that name. Thank you. I'll fix that. And I think I called this something else before too. No, I kept it capitalized. Close enough. Thank you. There, that's better. So the 1 is because at a minimum I need the GPA slope. And nothing else in here that doesn't have GPA, okay? When you're finding these simple slopes, everything in your line needs to have that, the variable the slope is for, or it doesn't go there. So what I'm doing then is turning it on if I want graduate equals 1, right here, for these two, for instance. And if I want private equals 1, I'm turning those on as well. So if you don't want to type as much, you don't have to write the ones that are 0. It will reduce to just that. But I leave them in because these are eligible to be used. So I do that for my own edification. So now we can get the GPA slopes for any combination of moderators that we want. So this is the same kind of command that we can use to find the difference in slopes. So for instance, what if I wanted to know whether this interaction was different than that one? The way I would do that is take the first one and multiply it by -1, and the second one would be 1.
Do you need the first term to do that?
This would not be in here.
Okay.
Yeah.
I
Yeah,
just
just
wanted
these
to,
two.
just making sure my brain was right when I did stuff.
Yep. And if you try this and get the answer wrong, you put the -1 in the wrong spot. It's a sign difference in the way that it's registered. So, same idea of linear combinations, but the negative sign means a subtraction. And so I have in the comments then what is actually happening in this code. We're adding together beta 1, beta 4, and beta 5, for instance, in this line. If you want to get odds ratios for these linear combinations, you can do that. So for the model, OR gets me model implied slope odds ratios. And then the lincom, if you add comma OR, you get the EXP version for those two. And the output will be labeled differently so that you can see that that's what you've asked for. Okay, Stata users, any questions on any of that? Zoomers? They've been quiet today. Good, okay. All right, our users then, let's see how it looks for you and we can walk through the model. So, it is a colon in R to fit interaction terms. Here's the results of my little function that puts things together neatly. So my intercept, has that changed in interpretation relative to the main effects model? Previously we said that was for GPA 3, no graduate degree, and public school. Do I need to refine any of that, or are we good?
Can you restate your question?
Yep. Intercept in the main effects model previously, we had said was specifically for someone with a GPA of 3, parents didn't go to grad school, went to public school. My question is, do I need to refine that interpretation in this model? No, I don't. Why not?
Because you just added interactions to be able to talk about each of the categorical variables differently, not necessarily to change the predicted outcome.
Yeah, we're adding terms related to predictors we already have, but we're not adding new predictors that would further condition the intercept on age or like some other thing, for instance. So yeah, we are changing what the intercept is predicted to be because it's a different model, but what it means is the same. GPA will be different as a slope relative to the previous model because it does mean something else. This is the GPA slope specifically for somebody who did not have parents that went to grad school, who went to public school. In terms of patterns, there, very big. This is a positive slope, right? What is it in people who have parents who went to grad school? Yeah, less positive. Is it stronger or weaker? Weaker. Yeah, signs are opposite. That's your clue. Same pattern for this interaction with respect to GPA. I can also think of it the other way, though. I can talk about the effect of having had parents that went to grad school and how that changes as a function of GPA. And that would be also less positive, weaker. Yes?
When we see these patterns, and we have two predictors that are both positive, when they interact with each other, they make each other less positive. Is that a clue that we might have some collinearity between those two predictors? So, like, one of them is already partially accounted for because students with a higher GPA and students who are more likely to have parents who went to grad school might both have higher socioeconomic status or something like that. So there's some kind of underlying factor that's not in our model, but it's like both of them are tapping into the same thing.
Okay, question was, is it possible that when we see this pattern of what would be called an under-additive interaction, like both of these things help, but they don't help as much as you would expect when you have them both? Is that due to collinearity or relationships among the predictors? I think it could be. I don't think it's necessarily has to be, because that's already been factored into what these slopes are. Like it's reflecting what each of them brings to the table uniquely. And we're just saying that what they bring is conditional on this other variable. But I think in practice, yeah, like if you already have an advantage, getting another advantage isn't going to benefit you as much. Like you're kind of out of room to show the advantage. And these are all in logits, mind you, too. So All right, and however, as expected from our likelihood ratio tests, interaction terms aren't significant. So we would talk about, non-significantly weaker or something like that. Yeah. Here is a test of our two new predictors. So note that I'm referring to model 2 main now rather than empty, and then model 2 interaction. Same result. Now our folks, here's how you get model implied slopes. This is a lot less transparent, unfortunately. I haven't found a better way to do it. Vladimir, do you have any better functions besides GLHT to do this kind of thing?
No.
Nope. Okay. Well, then they don't exist. All right. If he doesn't know about it, they don't exist. I just assume if I can't find something that it exists somewhere and I'm just not privy to it. These numbers are multipliers. So they are in the order of the fixed effects as they are printed in your output. So you need to refer to that. So what this, let's do the last one, for instance, since that's the one that's most complicated. So what this pattern is doing is saying, I don't need anything with the fixed intercept. Leave that out. I need one of the beta 1s. So that's why the second column is a 1 throughout, because each of these is starting off with what the main effective GPA slope would be. And then it's adding to it. I don't need the main effect of graduate or private, because that doesn't have anything to do with the GPA slope. Even though I want to know what the slope is for these things, these go into the interaction term spots, not the main effect spots. So for the last one, I don't need the main effect of grad. I don't need the main effect of private. I do need beta 4 if I want to turn this into a 1. And there's the same, that one. There we go. Oops, lost my eye. And I do need this one to be a 1 as well.
So whenever I'm hunting for a slope, the first thing in that list of multipliers is going to be a 0.
Yes.
I don't want my intercept. I'm not counting the intercept, I'm just looking at the slope.
Yes.
But if I'm looking for a predicted outcome, I'm going to include the 1 in the first column for the multiplier for the intercept, and then I'm going to add whatever the fixed effect is on top.
Yes, let me say that again for the Zoomers in the recording. So the first thing here is an intercept. If you are predicting some kind of slope, this will never ever go in it. Ever. But if you're predicting an expected outcome, then it has to start with an intercept. The question is, what else do you need conditional on the predictors you're creating the prediction for? So yes, I would recommend like doing this in your head or on paper or something to help you write these things. It's like, this is your ingredients list. Then you can customize who you want the prediction for. To get predicted probabilities, then, for plotting or otherwise interpreting. So I'm using a function called prediction that works like state margins. And type equals link. What does that tell me that these numbers are in? This is the link function, which means, yeah, logits. These are logits. So you have to just know that. It goes into this model, figures out what the link function was, and then spits back what it should be. So I am asking for predictions across a range of 2, 3, and 4 for GPA, 0s and 1s for the binary predictors, and here is the resulting table. Now if I want to turn these into probabilities, what is it called to go from logits to probabilities? Yeah, I said that one. Inverse link, there you go. So I knew it was coming, we just had to get there. Inverse link, to unlogit it, e to the logit over 1 plus e to the logit. So you can take that little formula and apply it to all of these, or switch out the type to be response, data scale. And it works the same way. This essentially means data scale inverse link. It goes in and figures out, oh, there must be probability for this. And here are your predicted probabilities. And Vladimir, this is like your 5-minute warning. Okay, you're up next. You're on deck, as we would say in baseball terms. So I made some pictures. I made these pictures in Excel. Sorry, not sorry. It's faster and it's useful for pedagogical purposes to see how the numbers work together. So I have a picture here on the left in logits. GPA is the x-axis, and then I have different lines for different combinations. So the red lines are for the folks whose parents didn't go to grad school. The blue lines are for folks who did. The solid lines are for people who went to private school, and the dashed lines are for people who went to public. So I would recommend building your colors and patterns in this sort of way if you have like this 2x2 arrangement, so you can clearly say, as indicated by red versus blue, here's the effect. As indicated by dotted versus solid, here's the effect. So these are straight lines because these are linear slopes in logits. So it looks like, just from eyeballing this, the strongest relationship from GPA to logits is for the folks who had no degree and public, although each of these slopes is like non-significant, I think. Now over here, I have used the predicted logits, turned them into predicted probabilities, and now that's my y-axis instead. So you start to see a little bit of bendiness here, okay? And it's not that obvious because I only plotted 3 points, but if I did a more gradual plot, it would look like this. Why is it getting bendy?
Because we compress the bound.
Because it has to shut off at the boundaries, and so this line is approaching 0. It's going to keep getting flatter and flatter and flatter. So it can be tricky to interpret things because this looks like a nonlinear effect, like a quadratic slope or something, but it's not. That's just what happens when you back translate into probability. You get this compression at the ends. And here's some words.
Words and numbers.
Yes, words and numbers. This is how I would write up a result section like this. So any questions about any of this?
Could you quickly go back to the part where you were showing us in R how to get the probabilities for specific outcomes? Because you were showing us that we can get a range.
Yep.
So -1, that means that you're requesting 3 outcomes, and it's a range of outcomes from 1 below the intersect, and 1 above the intersect.
One above and 1 below 0 as the centering point. Yeah, and that is what the intercept means, but it's relative to how you scaled the variable. Yeah, so it turns out to be 2, 3, and 4, which in the centered version that's centered at 3, it's -1, 0, and 1. Yep. There's various ways to ask for ranges in R. This is just one that I happen to know.
So with this one, if I wanted to go by halves, would I have like a by 0.5 in here someplace?
Yeah, that's a different one.
Okay.
It's like, I think it's SEQ something,
Okay.
sequence, Vladimir,
I think so.
something like that.
Okay.
Yeah, I think you'll see that in one of my other examples because I found that before.
This one's defaulted to go by ones.
Yeah.
Okay.
Yeah, that's what happens.
Perfect.
One more question.
Yeah.
So, I was taking notes. When we check for the inverse link, we're requesting type equals response. But when
Yes.
we're requesting the
The link, or the logit version.
logit.
Yeah.
Okay, type equals.
Yeah, so odds is this weird intermediate between model and data scale that doesn't exist in other models. So like once we get to counts, there's really not an analog middle that people pay much attention to. But yep, type equals link means model scale, which is logits. Type equals response is data scale, which is probabilities. Okay, get rid of that. All right, Vladimir, it's your turn. I gave you a warning.
Bring us
No,
three
no more
out,
deck.
Vladimir.
You are the.
Yeah, you're up. And you can have the rest of the class. We have a half hour. Let me get your, here we go. I gotta get your stuff open. 1 second. So there is a zip folder on the course website that this material is in. He gave you a lot of stuff, so a lot of resources to make work. Here we go. So which one do you want open?
The HTML file,
Okay.
yeah, that would be enough. And the R file, yes, if you can. But the R file would be just.
I don't know if R works on this machine, but I can open it in, oh, that's a R Markdown. Well, let's see. I'm not sure which version of R it'll be.
You can open it as a text file.
Oh, I can? Good.
Yeah. So that should be an open Windows.
I haven't unzipped it yet. Hang on, let me do that real quick. Oh, it's opening R, but
Ooh,
I mean, what do you study? Like, what do you study?
your major.
About the project?
no, he's one of my PhD students, so he's majoring in quant.
Oh,
Oh,
sorry, yeah. That's what I'm here asking. Thanks for that.
Okay, there. Is that good?
Yes.
All right, then Zoomers. Hang on here. Let me get you guys out again here. 1 second. And I lost the chat window somehow too. Very odd. Hang on. I'm gonna stop the screen share for a second, get my windows set up again, and reshare. Okay, there we go. Now we're back. Okay. Have
Awesome.
fun.
Thank you, Lisa.
Thank you.
Okay, I cannot see the camera here, but I'm assuming that you can see me, right? People on Zoom? Yes, thank you, Lauren. Because I cannot see our camera here. So. Yep. Okay. Hi, people on Zoom. Hi, people in the classroom. Thank you for being here. Thank you for the time, Lisa. Today, I will be covering some aspects of a study I was involved in back in 2021 about probabilities of being admitted in higher education in Chile. That's part of what I do in terms of research. My area of expertise is the admission to selective higher education in Chile. I participated in different type of projects, and this was the first thing that I led. So this was very special to me. Today I will be showing you an updated version because I updated part of the R code. For this version specifically, I have R and base R and dplyr R. Back in 2021, I learned how to use dplyr R in computer packages with Professor Brandon Labo, but that course is not being offered right now. And
I think Ariel's taking it over for the fall.
and maybe will be available next semester taught by Professor Ariel Aloe. So if that's a thing, my recommendation is take it, because when I took it, it was pretty helpful. When I came here, I didn't know how to use R at all, and that was like my first experience, and I learned many things. And so, about the project specifically, this is related to factors that could help us to predict the probability of admission in higher education. In Chile, the admission system works or is based mainly on your performance in tests. So you have test scores, you use those test scores to apply for different programs across different universities, and then you can be selected based on your performance. Now, each test we have, for example, math and language are mandatory, and then you have some optional ones, physics, chemistry, history, and one more, I think. So those tests have specific weights for specific programs within a specific university. You can apply up to 10 different programs. So based on your performance, you are selected or not. So our interest back in that year was how these academic factors can help us to predict the probability of admission in addition to non-academic factors, mainly socioeconomic attributes from students. So we considered students' biological sex, socioeconomic background or income level, family income level, and father and mother education level. So I will give you some descriptions later, but basically what we wanted to see was the predicted capability of these academic and non-academic factors related to the probability of being admitted to higher education in Chile. That's the project. So the RStudio. Okay, the HTML file, just 1 minute to say that the HTML file was created using R Markdown, which is something that you can use in R. This is amazing because using R Markdown, you can create HTML files, Word files, PDF files, and PPT files. So you can customize everything. So this is in the folder, and I included because if you want to replicate or use any part of the code, you can copy and paste. And as you can see, I always try to specify what I'm doing at every step. I know that in terms of code, every person has a different style, but my recommendation is try to standardize what you do, thinking about people that can read your code. So if you need anything, feel free to copy and paste anything, and you can email me with questions. Here I will show you how to manipulate data, because data is never ready to be analyzed. Once you download or you receive data, like half of what you will be doing is preparing data for analysis. Once your data is ready, feeding models, interpreting results, plotting results is just the other half. First of all, you must have your data ready, and you must be able to identify problems. I will mention some that we faced some years ago, and those details can be significant for the things that you are doing. So 2 tips. First of all, in terms of code, try to be as transparent as possible and prepare your data properly. Okay? If you need something, this is the code. You cannot run it, unfortunately, because you don't have the data sets here. Those are private, but you have everything else, okay? That's the R file. I give you a little, something about the context of this project, R Markdown files, the introduction. I also talk about the course, yes. So let's go to see the datasets. We had 4 datasets here. So in the admission process, students provide information about their schools, their families, their personal information, and academic records. And then they will have the test scores that are used to create the composite score used to apply to selective universities. So our data set look like this. We have a student ID and a school ID, and then we have these admission factors. NEM is the standardized score related to your GPA in secondary education in Chile. So you have 1. You cannot change this score. Ranking is the standardized score of your relative position in your school given your GPA. So these 2 are related, and you cannot change these scores across processes because you can participate in more than 1 process. In terms of the test, here we were considering language and math, which are mandatory tests. So these scores, the scale of these 4 factors is 150 to 850. So you can see that 1 unit in terms of this scale is huge. So then you will see that what we did, aside of centering these predictors, we reduced the scale, dividing the original values by 10. So now the 1 unit the 1 unit difference, the meaning of that is per every 10 points in the scale of the predictor. Yes. No, yes, please.
Maybe I missed it, but when you have the schools there, those are ranked according to something, or no, they're all the same? So if you have a score in one school and the same score in the other school, it's counted the same, you don't have to weight it or anything?
Exactly. No. Scores are individual information. So people can have the same score, and that means that they had the same number of correct answers in the test. That's another discussion because these scores are related to a CTT perspective, classical test theory measurement. Now they are using IRT, so they have another scale, different thing, but that started back in 2023. But that's another discussion. For now, same scores are possible, and that means that students had the same number of correct answers for that specific test. Now,
Yeah, I mean, just like
Oh.
like if there's a difference in the school
Oh,
ranking,
yes.
and if that impacts the weight of those scores at all.
Oh, sorry. Yes, ranking scores, the same ranking score doesn't have the same meaning because the relative position in one school is different to the same GPA in another school. Now, in the way that they constructed these standardized scores, we can use them without thinking about weights or something else. So, but yes, we can have same GPA or same NEM, but different ranking. Yes, because the relative position is different across schools. Okay.
Like I could be first in my class with a 500, and you could be first in your class with an 800.
Exactly.
And we're both
Yes.
first.
Yeah, that's what I was sort of wondering.
Yeah.
Yes. Yeah, but for now.